Welcome everyone, good morning. I'm so pleased to welcome you to our third webinar of the 2024 series. My name is Satwinder Paul. I'm an associate teaching professor in the Water and Wastewater Technology program. And with a team of experts, I run the online help center for BC Small Water Systems. Before we begin, I like to acknowledge that Thompson River University campuses are on the traditional lands of the Tecumseh Secwepemc and the Tikselek within the Secwepemc Ulu, the traditional and unceded territory of the Secwepemc. Thompson River University, with their partners, host an annual webinar series and courses dedicated to providing technical information, resources, and tools to all small water system owners and operators and indigenous small water systems on issues of treatment, regulations, operations, maintenance, and water quality monitoring. The webinars are scheduled for every 2 months in 2024 and is offered free of charge. For attendees who are EOCP certified operators, each webinar will count as 0.1 CEUs towards your certification. A certificate of completion will be issued to the webinar participant, which then can be submitted to EOCP. Today we will have our 1-hour presentation first, then we will follow that up by a half-an-hour question period. During the duration of the presentation, if you have any questions, please jot them down in the question section, and we will make sure that we address all of your questions during the question period. So let's begin our webinar. Today, our webinar focuses on cross-connection control and small water systems. This webinar presentation will discuss cross-connection control awareness and key cross-connection control program components for small communities and what water operators can do to protect the potable water system from becoming contaminated as consequence of backflow incidents. Topics include basic hydraulics, common cross-connection applications of backflow devices, facility hazard assessment, and basic key components of cross-connection control program for small utilities. And our presenter is Trevor Hoff. He's a cross-connection control specialist, instructor, and a consultant for MTS, Maintenance Training Systems, located in Vernon, British Columbia. He's a cross-connection control specialist, providing certification training and consulting services, and has been working with BC First Nation water and wastewater operators, municipalities, and private industry throughout Canada since 2003. Trevor's specialty is implementing cross-connection control programs and conducting facility hazard assessments. Trevor currently is a co-chair of the BCWWA Cross-Connection Control Education Advisory Committee and chair of the Canadian Cross-Connection Control Coordinating Committee. Trevor is a well-known instructor providing cross-connection control certification and confined space entry courses. So welcome, Trevor, and I will let you begin your presentation. Thank you.
Thank you, Satwinder, and welcome everyone. So today, as Satwinder was saying, we're going to review cross-connection control issues for specifically around small water systems and smaller communities and that sort of thing. So we've got a lot to cover in an hour, so buckle up, put your trays in the upright position, and we are going to get on with it. So cross-connection control, it's a mouthful and it's hard to get through all that stuff. Nice job, Satwinder. The issue with cross connections is that we often forget about that in our utility because we're too busy, putting out other fires, trying to make sure that we've got our treatment plants going and everything else, and distribution system, water testing, sampling, and we forget about the things that are connected to our distribution system that could cause contaminants to enter the drinking water supply. So, if these incidents occur all the time. Sometimes they're very dramatic, and other times they're go unnoticed. So it's a part of the multi-barrier approach system for operators. We focus on source protection, treatment and disinfection, storage, distribution system as far as piping, cleaning and flushing, sample and testing, operator certification, and cross-connection control is one of those components of the multi-barrier approach that often gets neglected, and it's often the weak link at the chain in our multi-barrier approach. So to start off with, let's just review an incident that occurred in a small utility, a small water system where hair was coming out of the drinking water supply. So that red flagged everybody. They made some calls, they came and sampled, and sure enough, they wanted to do a water sample, and there was hair in the aerator in the kitchen faucet. So one of the fellows noticed it was deer hair, because he was a fly fisherman and recognized deer hair right away. So the immediate thought was, well, let's flush it out and see what happens and try and get rid of it. So when they flushed that system, more and more people started to report that they had hair in the drinking water supply, and it was just spreading through the system. So where does this stuff come from? So the nothing in the reservoir, they're doing treatment, they're doing everything right. But what we're overlooking is cross connections within the distribution system or within a private utility, or sorry, the private sector of the buildings. So this was from just a residence who had a hose that was happened to be a hunter and was soaking hides. And so these were deer hides soaking in a bathtub. And then they had a garden hose that was just sitting in there. So that's a cross connection. And it was overflowing, and they just let it run and run and run. And so when they flushed that hydrant, it created a backflow incident and siphoned everything in that tub. And every time they flushed that hydrant, it would also repeat the same conditions. So it's understanding what a cross connection is and how backflow incidents occur as far as the hydrology and that sort of things, how all this happens. So by definition, a cross connection is any actual or potential physical connection between the drinking water system and any source of contaminant in such a way that contaminants can enter the drinking water or the potable system through the cross connection that you've made. So in simple terms, it's a plumbing connection between the drinking water system and something that is non-potable, such as a garden hose. And that's from every residential facility to industry. Another very common cross connection are just janitor sinks, where we have hoses connected inside under the overflow rim that can allow contaminants to enter the drinking water supply should it be left running or there's a leaky faucet. Salon sinks are another one. So these are common cross connections that you'd find in small communities, and soap dispensers are in every sort of office building or school, that sort of thing. And so they are, again, connected to the drinking water supply and sometimes connected to the janitor sinks, and they add to some confusion with that as well. Trap primers are a cross connection where you've got water supply that feeds into a floor trap primer. So this keeps the sewer smell from coming up into a room by adding water to it. So that is a cross connection that is a severe hazard because it's connected to the sewer system. That's what it looks like on the other end inside the trap primer, but is a very common cross connection in commercial buildings or in some homes and in floor drains in bathrooms and so on and so forth. Submerged outlets are another type of cross connection that are irrigation boxes or outlets for flowing or submerged in liquids. Livestock watering is another one. So for agricultural, some utilities are very small and rural, so they just have a lot more agricultural components to them, and livestock watering is definitely sort of a common component to that. right up to maybe there's an industrial plant or something a little bit more complicated in a smaller community that community is supplying water to. And sometimes, there's connections that are pretty more complex than a garden hose. So in this case, we've got fresh water system here, which is our potable water system. And this is treated effluent from sewer plant that is used for irrigation purposes. So it's treated effluent, but they're cross connect between the drinking water supply and the sewer treated effluent, including this blue item over here, which is a chemical injector and clean. So a severe hazard cross connection that is a little bit more complicated, but that's something that could be in an industrial application, even though you're in a small utility. So those are examples of cross connections. So backflow is just a hydraulic term, means flow in reversed, caused by backsiphonage or backpressure. Backsiphoning is caused by a negative or reduced pressure in the supply pipe, causing a vacuum. So these can occur in two ways. You can have a backsiphon due to supply pressure or loss of supply due to a water main break, where everything just drains from the cross connection through the facility, through the service connection, and into the water mains. So that's just straight backsiphoning from an upper elevation to a lower elevation that are both open to atmospheric pressure. The other type of backsiphoning that can occur that we often forget about is high velocity flows. So whenever water flows through a distribution system at high velocity, we lower the pressure in the system. And some areas in our distribution system, we can drop that pressure and create a backsiphoning situation. So normally, there's enough pressure in our water systems to sustain pressure to our elevated buildings or our infrastructure or distribution system. But if we're withdrawing a lot of water at a high velocity through, let's say, flushing a hydrant, that pressure will drop, referred to as our hydraulic gradient line. If that hydraulic gradient line drops below the elevation of the plumbing fixtures, those facilities or outlets or plumbing systems that are above that hydraulic gradient line will be subject to backflow incident. And so any unprotected cross connections will enter the building or enter into the distribution system at that point. And this can vary in hydraulic pressure loss. So for example, back to the hair in the drinking water supply is situation where we're under normal flows, everything is positively pressured, water system works as usual, but when we flush that hydrant, we lowered the hydraulic gradient line below the elevation of that building. And then any connections or cross connections, instead of a pool that happened to be a tub with a hose in it that was soaking deer hides, well, that just created a negative pressure and back siphoned through the system. And when they shut that hydrant off, it left a slug of contaminant in there that is quickly removed by other people using the water in that area. So often, even when you're sampling, you'll miss that sample because we often tend to run a water sample by running the water a lot and pulling it out of the main and seeing what kind of bacteriological samples we get. But we would miss that if it was a chemical or if we just flushed it out of the system. So often cross-connection control incidents go unnoticed. The only thing that gave this one away, of course, was the hair left over in the system. So things that cause, or situations that cause these back siphoning to occur are just firefighting situations where they're structure fire. That'll drop our pressure in our system, creating backflow events. Water main breaks, hydrant flushing, those types of incidents that occur. So that's back siphoning. The other type of backflow incident that can occur is something called backpressure. And that's when you have two different systems interconnected. So there's a potable system and a non-potable system. So if the non-potable system is operating at a higher pressure than the incoming supply pressure from the municipal side or the water purveyor side, that can be forced backwards into the water mains by means of a pump, boiler, because of thermal expansion due to heat, or elevation of water too. So inside of buildings, there's lots of different pumps and recirculation pumps and heat pumps and cooling pumps. And if that pump, or if the system supply pressure drops below what the pump is running at, then everything will back pressure into the building or the mains. So the picture here with a hose connected to a swimming pool. So that swimming pool is recirculating at, let's say, 30 PSI. The incoming supply pressure at the hose bib is, let's say, 60 PSI. But if that system pressure drops at the hose bib below 30, then the pool will simply be emptying into the distribution system, along with backwashing the filter and the sewer connection that you see there. That can also impact the water quality. So there are heating systems, pressure pumps, or car washes with lots of pressure situations or higher pressure than the distribution system. So these are the type of things that, you know, can show up in any utility that, you know, has those types of systems. And elevation in BC here and other parts of the world here, if your distribution system is on different elevations and you're supplying to different plateaus and different elevations, well, the weight of that water can also impact, should you lose pressure or loss of pressure, that can all, you know, drain back into your system due to the weight of that water. Okay, so just some basic hydraulics on you know, the items that can cause back pressure, back siphoning, that we sort of we forget about because we're flushing hydrants, we're going on our day, and we have water main breaks and firefighting situations. And so as water operators, we have to focus on what else is happening in our distribution system when these items occur. So methods of backflow control. So this is sort of, all cross connections are sort of assigned a hazard classification. And then there's typical means of isolating those connections by means of backflow preventers or an arrangement of piping. So in the case of hazard classifications in Canada, and anyways, there's the manuals and the standards divide these hazard classifications into three types. So there's a minor hazard and a moderate hazard and a severe hazard. Type cross connection and or type building. So everything's classified into these categories, where minor means you're not really going to be, there's not really a detrimental, there's no detriment to health or anything. It just changes the aesthetic quality of the water. Moderate hazard would be sort of something, the aesthetics of that water are already degraded, but there's a low probability you'd get sick. And a severe hazard means if we ingested any of that system or that contaminant, that it would cause death, or it would cause some sort of communicable disease or illness if we were to ingest that. So example of a minor hazard would be just beverage machines or juice machines that are connected to the potable water system. Moderate hazard would be fire sprinkler systems or irrigation systems, that sort of thing, where it's that water could be compromised and we would have a low probability we would get sick from that. And some of them are better than others in this watering trough incident here, where, I mean, that's, again, you could get sick from that. So that's what it's saying. But fire sprinkler systems are a typical moderate hazard as classified by standards here. Severe hazard cross connections would be anything chemical that is added to a system in heating and cooling systems, sewage, wastewater interconnections such as sandy dumps or wastewater treatment plants, wash down hoses at plants and things like that, car washes. So smaller communities may have a campsite or a sandy dump station, small wastewater system, a car dealership or something like that that you'd see in is where that blue tub's coming from there. That's just from a automotive system, but they have a connection to those chemicals. So that would be a severe hazard. So buildings are classified into these hazards as well. So minor, moderate, severe hazards that as well. So most small utilities would have, like your school or your daycare center or office building, maybe it's a small municipal hall or a band office, would all be sort of a moderate hazard. Whereas your severe hazard buildings would be the hospitals, if there was one, but a smaller utility might have, you know, the lift stations, the wastewater treatment plant, that sort of thing. Car wash are notoriously bad because the last incident we had in actually Canada was that was due to back pressure was from a car wash in Stratford, Ontario. Methods of backflow protection. So how do we control these cross connections? Where do we put everything so that we can isolate these cross connections and ensure those contaminants can't enter the drinking water supply? So we can do that by adding backflow preventers internally inside a building to ensure that all the cross connections in the building, like the janitor sinks, the fire sprinkler system, the irrigation supplies, the boiler makeup or the water supply to the heating systems, are protected by a backflow preventer. And that protects the occupants of a building. And that's really what the plumbing code primarily focuses on, to protect the occupants. The other type of connection or isolation method is something called premise isolation or protection. And that's a containment type of installation where you install a backflow preventer on the main water service, and that isolates that particular facility from the distribution system. So it doesn't necessarily protect the occupants of the building, but it will isolate that substance from spreading throughout your community, and is also mandatory by the plumbing code for any severe hazard classification buildings. So we have to have a backflow preventer on severe hazard facilities as premise isolation. So internally, this is just an example of a utility sink, which is pretty common. And there's a backflow preventer called an atmospheric vacuum breaker on that built into the fixture. So it's integral into the fixture. That prevents anything from getting sucked up into the drinking water supply from filling up the mop pail or whatever. Premise isolation, the location of the backflow preventer, if this is sort of bird's eye view looking down, you have your distribution system service connection into the property line of a building. We could put the backflow preventer just inside the property line, let's say, to isolate the entire property. Or often it's installed inside the building, which is, you know, easier for protection from freezing. It's not a confined space then if it's in there, and it's more accessible for testing and maintenance and that sort of thing. So often different municipalities or different water purveyors will decide on where this goes. Maybe it's either or. In cases it can fluctuate based on the property, but that's one method of isolating. So again, mandatory for severe hazard facilities. This is a typical what it would look like. You'd have a shut off, a water meter if there was a water meter, and then you'd have a backflow preventer, which is that thing right there. And that's an RP. Usually there should be a drain and stuff underneath there. That's one thing we'll get into in a sec, but that isolates that building. Now, for small water utilities, small water systems, a lot of the time, you know, you'll see these backflow preventers. You might recognize these backflow preventers, but unless they're installed properly, they're not going to maybe protect you from a cross connection, or they're going to be an added problem to the way it's installed, might flood a building or something like that. So I'm just showing some, I mean, there's lots of installation stuff in an hour here. We don't have a lot of time to go through this. So it's just some important notes that you should be aware of in your utility if you see this sort of thing. So one of them is you cannot have a bypass arrangement around a backflow preventer. So I inspect a lot of facilities and things, and I see very common. It's an installation nightmare that we're seeing these bypasses installed, and you can't have that because the contaminant can back pressure or back siphon right around the whole backflow preventer. And a shutoff is not considered a means of isolation according to any standard or any backflow manual. So the shutoff valve doesn't count. And so this piping around there's a backflow preventer right there. So the piping around these system here, they have to go, or at least another backflow preventer of the same type has to be installed on the bypass arrangement. So keep an eye out for that. If you see these backflow preventers, make sure that there are no bypasses around them, okay? So we can't have that as far as the plumbing code goes, as well as the standards. So again, just to, even if you have a backflow preventer, you see one and it's being tested every year and everything's functioning perfectly, but you can still have that event if your pressure drops, incoming supply pressure, and the pump on that boiler due to thermal expansion of the pump is greater, it will back pressure that contaminant, the glycol or whatever system or heat medium that they're using in there into the potable water supply. So it's a false sense of security if you think there's a backflow preventer there and it's not functioning properly. Okay, so there's a backflow preventer called a reduced pressure principle. It's referred to as an RP. And it has a discharge port on the bottom. It's designed and functions so that if one of the check valves fail, it will discharge at the bottom of the relief valve port, indicating its failure and indicating, and discharging any contaminants that could be coming in the reverse direction. So because of that discharge port, an RP cannot be installed inside a pit or anything else. This happens to be installed in the wet well in a lift station. So if that lift station is submerged in raw sewage, so is that backflow preventer, and so you have a cross connection that is a very severe hazard type of connection. So back in the day, a lot of these systems were engineered that way to provide a hose bib inside a lift station to wash out the lift station and that sort of thing. But obviously that's a very severe hazard cross connection. But by installing a backflow preventer inside the wet well is not the means to protect that from that contaminant. So that has to be all dug up and disconnected and that sort of thing. So if we're going to clean the lift station, you're going to want to use a standpipe with a backflow preventer on it, a hose outside of the confined space, right? Or outside of the lift station. Another thing about an RP or a reduced pressure backflow preventer is that it has a discharge port and will discharge a lot of water should the check valves fail. So on this diagram or this image here, they're just demonstrating how, a 4-inch backflow preventer here will discharge, 500 gallons a minute at 75 PSI. So unless there's a drain allotted for that discharge during the build or that construction, then there's just a flooding hazard waiting to happen here. And insurance companies may or may not even honor that insurance claim if it was not installed properly. And a lot of these get installed incorrectly. So, as a water operator or somebody seeing these backflow preventers, it's not just a fact that, again, that they're there, but that they're installed correctly and that there's proper drainage underneath them. Also, if you install a backflow preventer on a main water supply, or there's a hot water system or a heating system downstream of that device, you've locked that expansion in. When that hot water gets hot, it needs a place to expand. And with a backflow preventer, it can't expand anywhere. So that hot water will get heated, and it'll back pressure hot water down the cold line. And then if we don't allow for that expansion through a thermal expansion tank, then the hot water tank is going to be under a lot of stress. It's going to start discharging under the temperature and pressure relief valve, and people will start replacing hot water tanks and all kinds of issues. But what we need is to just ensure that when a backflow preventer or pressure reducing valve gets installed on the main water service connection, that there's a thermal expansion tank accompanying the installed on the heating systems, and that's per the plumbing code as well. Some vacuum breakers that are limited to backsiphoning conditions only, cannot be subject to back pressure. So therefore they have to be, the backflow preventer itself has to be the highest part of any downstream piping. And so if there's elevation downstream or heat or pumps, vacuum breakers will not function properly. So there's limitations on some of these different types of valves as well that we have to be cognizant of when we're observing or identifying these backflow preventers in our system. Okay. So what are some of the typical hazards in a small community and the type of appropriate backflow preventers that sort of match codes and that sort of thing? So in the small time frame we have to run through this, I'm just going to show you the sort of the images of a cross connection, so, you know, aside from the ones we just talked about earlier, and the backflow appropriate backflow preventers that are typically required. So some small water systems, maybe your system only consists of residential housing, in which case really the only, as far as private buildings, the only cross connection we need to worry about are the outside hose bibs. And so we can have two methods of controlling those. So we could install on older buildings, right, they'll have these hose bibs that you're looking at there. You can thread on a hose connection vacuum breaker, and that will protect anything from getting sucked into the water supply through backsiphoning. So if that system was on our deer hide incident, that would have never occurred. This is another type of built-in atmospheric vacuum breaker, a hose connection vacuum breaker that is a part of new homes now, so you typically see those on there, and that will prevent backsiphoning from occurring. I mean, they have their downsides as well. There's pros and cons to some of these things, but you know, the bottom line is we don't want deer hair in the drinking water supply. So that's one way of, a simple way of doing it. They're inexpensive as well. So, and so that's what I would focus on in a small community that just had sort of residential type buildings. Irrigation systems are pretty popular in some areas of the country more than others, right? It's in the Okanagan here, it's dry and hot, so there's lots of irrigation systems. And the irrigation systems are not designed to be drip tight, so they are, you know, subject to contamination with dirt and or you know, nematodes or residual hard fertilizers. It's not like they're injecting a fertilizers, that's agricultural stuff, different. But your standard average household irrigation system or green space park, ball diamonds, that sort of thing, right, can be isolated by something called a double check valve assembly, or a DCVA. There'll be a glossary at the end here, but that's a typical testable device. Cooling systems are can be somewhat hazardous because they'll use cooling and heating mediums in there. That's a swamp cooler there. It drains, you know, keeps straw moist, and you can have bacteriological buildup of different types of airborne contaminants, Legionnaire's disease, for example, and we don't want that in a drinking water supply. So typically that would be an RP, backflow preventer, stands for reduced pressure principle, or for low hazard cooling systems, that would be a dual check with atmospheric port. So different types of backflow preventers for different applications and different hazard levels. This is a walk-in cooler, cooling condenser. They're in ice machines, in your convenience stores and restaurants and that sort of thing, or in different types of subways and, you know, for pop machines, that sort of thing. Hydronic heating systems will be used for obviously heating buildings or for any industrial application. This one here, they're showing you that blue thing is where you'd add your chemicals. So this is where a chemical pot feeder. So these are severe hazard boiler type systems, and they would use an RP. Or makeup lines going to a heating system without a chemical in it and constructed out of potable piping like copper then you'd only need a dual check with atmospheric port. So again, you really have to know the application, the cross connection, and your backflow preventers to make the right choice of the backflow preventer you need. Fire sprinkler systems typically use a double check valve assembly. And again, they'll be in the large sizes. You find these in your distribution system. It could be in the office buildings, the city hall, band office, that sort of thing. Schools. Pop machines there's something called a post-mix beverage machine where it mixes your CO2, your water, and your syrup. And here we've got the mixing valve in the middle here that mixes all those things to make a pop. But if the CO2 back pressure, it's under a lot of back pressure, and if the regulators malfunction on that system, it'll back pressure CO2 into the potable drinking water supply. And when CO2 comes into contact with copper, it creates copper poisoning. And so you can get really sick from drinking that substance. So this backflow preventer is called a dual check with atmospheric port for carbonators and is installed right here in this picture. And often people don't even know that's what they are. So you want to see these under the counters. They're in pubs and restaurants and items like that. Soap dispensers are again everywhere. You'll see those in any janitor room, often connected to the janitor sink, and that will have a built-in integral air gap inside there. Hopefully, not all of them do, but that's what we want to see. You'll often see soap dispensers connected to the utility sink, and it's actually not the correct way to do that. They should have a designated supply. Otherwise, what you end up with is hot water back pressuring across into the cold water supply. And I see this everywhere. And signs saying, hot water may, come out of the cold water taps because so they're reminding everybody to shut off the water supply instead of just installing the soap dispenser correctly by having it on a designated supply, not off the dispenser or off the utility sink. Because not all atmospheric vacuum breakers, which is on the utility sinks, can handle back pressure if there's elevation or heat, because all this does is just run straight backwards and hold the air inlet valve closed up here, so hot water can just drain back into the system, or contaminants that are connected to the soap dispenser or whatever. So it's not really designed for that application. Salon sinks are pretty, prevalent as well. So on a salon sink, there's supposed to be an atmospheric vacuum breaker. They come as an optional purchase from a salon owner. When you're setting up a salon, that will be an optional device. This one here has no atmospheric vacuum breaker on it, and this sink here does. They're custom made. They run about, they're expensive, and so often new salon owners may or may not choose to order them from the companies. A lot of hydrants are being used for other than emergency services. So fire or hydrants, if anybody's going to connect for potable or for dust control or trucks connections or temporary services due to construction sites, there should be a portable RP attached to the side of the hydrant and supported properly for any non-emergency use. For trucks themselves, a lot of the new trucks now will have an air gap at the top of the truck, and if not, then they'll have to ensure that there's an RP on the fire hydrant. One of those two would suffice, but mostly, as far as water purveyors go, they will have a couple portable backflow preventers that they will install on the hydrant should they allow people to connect to their hydrants for non-emergency water use. If you have a lift station, we talked about earlier, make sure there's no connection inside the lift station. And if we're using potable water to wash out a lift station, then that should come from a standpipe. Outside the space, we should have an RP attached to the standpipe and then a designated hose to the lift station that does not go into the wet well. So in this case, somebody's holding that and flushing out the lift station appropriately with a backflow preventer. At best, a back truck's the best way to go, but of course, small systems don't have those resources. So the best way to do that is make sure you have the proper backflow preventer attached. Testing and maintenance of backflow preventers. Some backflow preventers require annual testing and maintenance and can be done by closing the shutoff valves, pulling it apart, repairing it, putting it all back together, and conducting a test to ensure that the check valves function properly. Now, of the different devices, there's a pressure vacuum breaker, an RP, or a double check valve assembly. So these devices here are all testable, and they get tested when they're installed, and then annually thereafter is sort of your best practice for time frequency. These devices here, the RP and the DCVA, actually can get up to 10 inches in size. So I mean, these things can be massive. Pressure vacuum breakers, or PVBs, tend to be up to the 2-inch range, but they will all be shipped with shutoffs and these test ports to connect your test gauge. This is the type of test equipment that a certified tester will come out and test the functionality of the backflow preventers to ensure that those check valves, shutoffs, and everything are working appropriately. Test assemblies are basically done on a test report and submitted. Somebody will document those, the functionality of those, to ensure they're functioning properly. They have to be performed by a certified backflow assembly tester, and the results, again, documented on the acceptable form. And as a tester, if I'm testing that backflow preventer, I have 3 copies. I send one to the water supplier, I keep one as a tester, and the other one goes to the customer. And so there's always 3 copies or triplicate or copies of forms. And if I receive these as a water purveyor, I want to keep these for record, my own records for health authority might ask for them, or there's other, documentation I need to do. But these things need to be tested annually if you can. We'll get into a little bit on that logistics around that. Sometimes for remote communities, that's rather difficult to do. So we'll talk a bit about that. But test reports are filed again for keeping. Testers should submit equipment calibration dates. So some of these gauges here, they are pretty sensitive instruments, and they get sometimes banged around and they lose their sensitivity sometimes. So these things have to be calibrated on an annual basis as well. And so that's often recorded on these test reports and is a requirement of a tester as well. So they have to keep all this equipment in good shape, as their own equipment as well. And so if you have a test report that you're getting filled out, that information should be on the forms. Okay. Failed assemblies must be repaired. That's another thing you'll get is the tester will come out, repair the backflow preventer, or sorry, fail the backflow preventer because it's not functioning correctly, and then leave it. Or the next year they'll test it again and it still failed. So what has to happen is these things, once they fail, they need to be repaired. And half the time, 75% of the time, they just need cleaning. So what you want to watch out for is somebody that's, failing a backflow preventer and then suddenly just has to order all the parts there is. And those parts can get expensive. You don't always need all those parts because we need to know what's failing. Half the time, if you take it apart, it just needs cleaning. You can reassemble it, put it all back together, and retest it to make sure it's functioning. If to take it apart to clean it, and if there's damaged components in it, check valves and that sort of thing, then a repair kit can be, acquisitioned or purchased. Now, for remote small water operators or systems, that's often a challenge. It can take months to get a repair kit for those devices. So it's ideal that you have a repair kit on hand, kind of already there, because that's going to save That's going to save you a lot of cost. If that person has to go back 2 hours into another community, come out a different day, they're going to charge you a charge out rate fee and travel each way to order that kit. But if you have one on hand, you can save a lot of resources there by that person can deal with that backflow preventer right then and there, put it all back into service, do a retest, and there's no extra cost or trips or anything made. So again, only replace the parts that are damaged. Now, some people say, well, we replace the whole parts. I mean, that might be fine on a 3/4 inch or 1 inch backflow preventer, but when these backflow preventers get large, up to 10 inches or 8 inch or 6 inch backflow preventers, these are extremely expensive parts. So, you know, if the other parts are functioning, then, and we can show that in a test report, then really we're only repairing the damaged parts of the other malfunctioning components. Okay, so that's just some of the sort of previews of that gets us to some knowledge about, you know, what is a cross connection program and what do I need to do as a water operator in my small community to ensure that I have a cross connection program. So it sounds daunting, and a lot of these programs can be, depending on the size of your community. But for smaller communities, we need to, you know, understand how do we build a program, where does it come from. So the authorities around a cross connection program are the environmental health officer, and through the Drinking Water Protection Act and regulation. So they mandate water quality in the province of BC, and other provinces have your own acts and regulations. The water supplier has local bylaw for enforcement of testing and maintenance of backflow preventers that customers would be required to do. The environmental health officer can also put a condition on your permit to operate a water system. If you know, they're going to focus on treatment and distribution system if that needs upgrading, but I mean, when that's all done, they could now focus on, okay, one of those other multi-barrier approaches, like how's your cross connection program? And if they're not seeing one happening, they could add that to your permit to operate as a condition, so they can enforce it through that. The building officials or housing departments have the plumbing code, and so all cross connections have to be corrected for new builds. Internal education is important when you guys get your program started, is that maybe water operators need to be a little bit more educated on cross connections when we're flushing our hydrants, that sort of thing. Building and housing, maybe they need to, you know, make sure that we have backflow preventers on our buildings or outside hose bibs, that sort of thing, or that they know some standards, the appropriate standards to follow when we're building new buildings. Mayor or chief and council should be informed on the importance of cross connection and that it is a part of the Drinking Water Protection Act, and we should be making sure that we have some sort of program in place. So public awareness means, you know, we're educating our public about cross connections. That could be on a flyer or web page or just discussion with people when you see a hose and stuff where it shouldn't be. Those are conversations to have with folks and discuss proper backflow prevention methods there. So more awareness means better protection for your water distribution system if everybody's aware of cross connections. What are the standards that are out there? So the plumbing code enforces the protection of cross connections. Now, there's only 4 pages in the plumbing code that we have here provincially and nationally. It's the same section. We had national plumbing code. I think Ontario is slightly different there, but they're the same section. But it's very light on or limited in its application. So therefore, they reference a standard called the CSA or Canadian Standards Group B6410, and it's the manual for the selection and installation of backflow preventers. So this is a mandatory code that the plumbing code says to follow when installing or selecting a backflow preventer. And that, needs to be, we have to acknowledge that and make sure that everybody's on par with that. So that includes our building officials, that includes our engineers and our local developers. And that's one of the things that is adopted in a bylaw, for example, especially for things that are outside the scope of the plumbing code, like my irrigation systems or my farm agricultural stuff. So it's still an important standard that has to be referenced. And that way, we're not referencing other standards that are not applicable in your area. So, you want to research where you live, wherever you're living, and make sure those codes and standards are appropriate. There are, so the national code is pretty much, like I said, the same throughout. BC has their own provincial code, and some of the provinces out east have their own codes and standards, but they're all referencing B6410 standard, as far as I know. Record keeping. It's important to, as far as your cross-connection program goes, is to maintain records of anything that's sort of, and it doesn't have to be that onerous. It just means, I have to have a file. I just have to keep things in a file. So should I need them, I'm going to pull those out and show them to whoever I need to for any enforcement action, or maybe there's legal defense. If a backflow incident occurs, then we need to have all our sort of ducks in a row. And how can I do that? Well, I can, I need to have proper record keeping. What would I keep? Well, I would keep documentation among all my backflow preventer, all the inventory of my backflow preventers. As far as the testable ones anyways, we want to make sure our pressure vacuum breakers, our RPs, and our double check valve assemblies are inventoried. I know where they are, the model makes and serial numbers, and what they're isolating. I would have test reports on those, and they would have, by certified testers. That documentation is a legal test report for legal purposes, so they're signed and dated appropriately, and they have to be filled out correctly. And those are kept in a file, and or for a few years anyway, so that I know if somebody asks for them, I can present them. Your cross-connection survey report should be done, and those are inspections or identifying hazards in your community. So should I have, that's one of the things that we're often forget about is if I just have 9 backflow testable devices in my distribution system or my community, and I collect those test reports, that's not necessarily a cross-connection control program. The Drinking Water Protection Act wants us to identify threats to our drinking water system. So a part of that is doing these cross-connection surveys so we can identify the threats, ensure that there are proper backflow preventers installed, and if there aren't any, to ensure that backflow preventers do get installed per CSA B6410, and that we mitigate those risks. All correspondence relating to cross connections or that program, including emails and correspondence with customers and maybe mayor and council or things like that, or supervisors. So we have to ensure that when we identify things, we acknowledge them and put those into play, and we document everything. So I've been called to many backflow incidents as an investigator to figure out what had happened, and when something goes to the legal side of things, they ask for a lot of information, so we have to be prepared for that. And often that's when we find out how good our program is or isn't, is when an incident occurs. So record keeping is rather important. Inspection of existing buildings. So new buildings are one thing, but the older existing buildings, the car wash that's down the road, nobody's saw, it's been there for years, and is there a backflow preventer in that thing? Does anybody know? What about our heating and cooling systems? What about fire systems in the school? What's happening? So do we know we have backflow preventers there or not? So it's important to inspect these buildings, identify cross-connection threats, document cross connections on a survey report form or some kind of reporting, determine if there's protection, if there is, documented, and if there isn't, require a backflow preventer. So for smaller utilities, if it's just residential, that's 90% of your facility or your community, then let's focus on those hose bibs, right? Let's make sure that all the hose bibs are installed. Now, one note, if they're built in, these are self-draining, that's fine. If you're going to thread one on, they make an indoor one and an outdoor one. It's important to put the outdoor one on because that allows the hose bib to drain so it won't freeze. And so those are frost-free hose bib or hose connection vacuum breakers. So we want to make sure those are frost-free. Otherwise, if you put the wrong one on, we're just going to freeze a lot of hose bibs. So watch out for that. But they're relatively inexpensive, $25, $30, $35, somewhere in there. And that's your half of your 3/4 of your cross connection program is isolating hose bibs in a small community. So not an onerous thing to achieve and can be done. For your commercial buildings, the fire hall, municipal hall, band office, daycare, clinic, those kind of things. If you're on the coast or there's docks with boat works, you need to isolate those. Lift stations we talked about, right? What about the maintenance shop, the public works yard? Those kind of things we have to look a little deeper into, see where our cross connections are in those facilities. What about our heating and cooling systems, that sort of thing. Check on our backflows there. New buildings, compliancy of new buildings should be done at the time of the build. So for building and housing, they should be informed of these standards or know at least, that they exist and what we're asking for when buildings are built. Engineering should be informed as well. So we're all on the same page. Are we going to do premise isolation? And if so, where is the backflow preventer going to go? Is it going to go inside the building? Is it going to go property line? Does it have to be in a vault? Well, then now that's a confined space. And so there's all these challenges that go around installing a backflow preventer for premise isolation. So engineering should be involved on some of these decisions where they're going to go. Remember, an RP cannot be in a pit, so that one would have to be an above ground heated enclosure. So all these challenges go around premise isolation. So engineering diagrams or policies around the CSA B6410 have to be established and then adhered to in our cross connection control program. What about annual testing? So our backflow preventers need annual testing, and so we have to develop that procedure, maybe a test report, get that out there. And when the test reports come in, where do they send them to? Where are they going to be stored? Last coming up here is an emergency response plan. So develop a backflow incident emergency response plan. So should an incident occur, what is our action plan? How are we going to do proper sampling? So they do make, or you can request from your laboratory, a specialized sample kit, because I know we're sampling for bacteriological and that's all good and well and good, but how do we sample for glycol from a heating system that gets into our drinking water supply? Or how do we sample for soap or other types of chemicals that are used in conjunction with some of these cross connections? So these are special sample kits that are done up for that. So you can ask your laboratory about that, where you're sending your samples to see if they can, put together a cross connection emergency kit. And they're relatively inexpensive, but it's one way to collect chemicals. Or should, I have copper poisoning from a pop machine. How can I need to sample for metals. So it's just a small kit. So that has to be, or recommend something like that. So how do we identify an incident is occurring? What about proper sampling techniques, right? Should I run the water, not run the water? Should I just grab a sample right out of the tap? Just to verify where this comes from. And then we got to find that cross connection, restore water supply, disinfect the piping, or swab or flush or replace water mains depending on the contaminant. And so some of this stuff can be pretty costly if you're replacing water mains due to some type of chemical. Okay, so having a good emergency response plan is for backflow incident is important. Okay, so to wrap it up here, what will a cross-connection control program do? It will protect the public water supply. It will reduce the risk of waterborne illness. It will ensure compliance with operating permits through the health authority. It will reduce the risk of liability to the water supplier. It will reduce the number of water quality complaints. You know, when your phone rings, when you're a water operator, it's always when it's not because they're thanking you for a great job well done. So when it's real quiet and nobody phones you, pat on the back for all water operators out there, because that's the same thing. Increase public confidence in our ability to protect the drinking water supply, and of course, increase awareness about cross-connection control. So the less people that are creating cross connections, then the less we have to worry about it. So, okay, so that's a very brief soup to nuts, start to finish on cross connections, and for smaller utilities, just focusing on what's in your community. Hope that was an expansive enough, and we flew through that. So any questions, you know, Satwinder will provide us some. So thank you very much for that and for listening to me, and hopefully we're on time here.
Yeah. Thank you. No, perfect timing, Trevor. And thank you for that great presentation. It is a very complex topic, and even the jurisdiction is quite complex, right? So especially in regards to installation. So we will take your questions for the next half an hour, and I will, once they're posted in the chat, I will read them to Trevor to answer. So Trevor, we have our first question. We have a campground on our water system. When they close in the winter and we turn their water off, will a vacuum valve prevent the stop and drain valve from working, draining the campground?
Excellent question. And so remember what we talked about. So a stop and waste has two drain ports at the bottom, and you can put an atmospheric or hose connection vacuum breaker on there. But if it's the indoor one, it will not drain down. So those will freeze your that standpipe. So you have to have one. There's some that have a black button on the bottom of it. When you undo the hose, the button falls down. It allows air to enter into the system, and it will drain down into the bleed ports at the bottom there, and that would be a means to drain that. Now, all fire hydrants and all yard hydrants at those bleed ports are a cross connection in and of itself, but there's nothing we can do about those. So we just have to make sure we install those with good drainage, good gravel, not in contaminated ground soil. But that's a common problem with campsites. The other issue is that if there's back pressure, if they're connecting it right to the RV is under back pressure in some cases. So as their pumps kick in, so is the water supply. So most of the time it's just the water supply into the tank, that's all good, or into the RV. So hose connection vacuum breakers work fine for that, providing you get it to drain. The other kind you can put on there is called a dual check. Just a little dual check that gets threaded on. It has a hose bib thread. A lot of campgrounds will spray the site number on it, take a credit card imprint. So the person puts it on, or the camp host will put it on the standpipe. And then if it disappears after they leave, well, they've got a credit card imprint. It's a small, not a testable one. It's just a small, inexpensive dual check. And then they can be removed in the fall for drainage of the yard hydrants as well. So a couple different options there.
Next question. We have a small summer use community, and while each cabin has a hose bib for watering gardens, but I'm unaware of any cabins where the hose end would be in a pool of water or fluids. Am I missing something?
If the If the hose is just used for, yeah, it's part of the code. So all hose bibs, according to the plumbing code, must have a backflow preventer on them. So there's no getting around that. That's part of the code. Now, the typical, you know, is this kind of thing, right? Where we've got an atmospheric vacuum breaker there. Now, without this, I've just got a garden hose and I can use it for all kinds of purposes, watering grass. If I have cabins and they're on the lake and I'm fishing and I'm washing out the fish thing, or I'm washing the cabin for the summer and I get there and I want to wash everything. It's just hoses in buckets, hoses in the lake, hoses in the hot tub, hoses washing out my septic tank in the RV, hoses for, you know, all kinds of weird stuff. So not everybody, deer hides, like, I mean, not everybody's using it for that, but we have that, you know, the opportunity for people to use it differently is important, and we don't always, know what's going to happen. So for the most part, yeah, they're just a standard hose. They're just using it, you know, but if it's laying down in the mud or laying down somewhere, it probably shouldn't. It might not necessarily contaminate your entire community, but it could contaminate water to the kitchen sink in that particular home and cause harm there. So it's some of them incidents are just, you know, very small. They're not sort of system wide. They're just inside the house. And so you know, the quick fix on that is must for the plumbing code, and for the old buildings, you can just thread them on. And again, just make sure they're the outside one. So hopefully that answers that question.
Thank you. How to find out that contract is properly certified for installation and testing?
Okay, so yes, not all plumbers are certified testers, or maybe they've let that certification lapse. Plumber can, when you're taking third-year plumbing, there's a 1-week course on certification of backflows, but it is optional. It's not a mandatory requirement to get your certification in that. So it's one of those things where, you know, you're going to have to ask that plumbing outfit, do they have a tester or someone who's a certified backflow technician that can install and test backflow preventers. So that's unfortunately just, you know, a plumber or fire sprinkler person are generally certified in backflow, but not always. So you have to ask.
Is there like a list somewhere on a government website where you can find who is certified and who's not? Does
No,
BCWWA have a list or anything like that?
yes, but they don't publicly produce that list. So
Okay.
it's only goes to the water purveyor. So the one thing you can do as a water purveyor is, if I've got a couple local other communities and a plumber here, a plumber there that are certified, I would collect those numbers and then have those accessible to my customers. If they're asking me as a water operator, hey, where do I get this stuff tested, or how do I deal with this testing or installation of backflows, is that you have an answer for them other than, you know, especially for smaller water systems. Maybe there is a local plumber, or maybe there is somebody who can become a tester to help with our community's testing. But if there's a fire sprinkler system in your community, that somebody has to come out at some point and look after that fire system. So that's a moment you can find that person. If they're a certified tester, they can test all your other backflow preventers, your other 5 or 6 or 2 that are elsewhere in your community, and get everything done in one shot. So check with the fire sprinkler companies as well.
Okay. Just a reminder that Trevor's presentation and the recording will be posted on the online help center by tomorrow. My question is, there's another question, sorry. Would the second edition of the Cross Connection Control Manual 2018 be adequate for training in a recertification case?
2018, yes, it would be. If we're talking BC, yes. There are changes in 2023 that haven't been published to the new manual yet. There are some changes between manuals, but they're slight enough that, I mean, you should get a new manual because there are changes. However, if you have a manual and the test procedures have not changed, and there's just some changes in the hazard classifications of some of the buildings and some of the cross connections, and there's some changes in the health aspects. So they've included radiological as a hazard that wasn't in the 18s, that is now in these books. So yeah, so if it looks like, I don't have one kicking around here, but if it's just a straight orange binder, then a lot has changed since then. If it's a ringlet binder with ringlets in it, that's the newer versions, and those came out in 2021. So I would probably say you're due for a new manual, but
Yeah, I think I have an orange binder sitting in the back shelf there.
yeah.
From old.
Right. I mean, recertification is, can you test a backflow, and can, you know, those procedures haven't changed, but some of the more practical stuff and application maybe have changed. So you might have some issues there with the written.
Yeah. Is there any open source manuals or anything that's available? No, or you have to buy the stuff,
Yeah, they're included when you take a course for your first year, and then they're optional. I mean, there's a lot of debate into that, whether or not, you know, just because every 5 years you should buy a new manual. So I think in BCIT they make you buy another manual, you know,
Okay.
places like that. I think, I'll take my word for it, but as far as I know, that's what they're doing, just because of that reason, right?
Yes.
There are changes. Mind you, the CSA is where everything comes from, so that that manual mirrors the CSA. So heads up, there is a big change coming up in 2023 last year. So there's going to be probably a new update in 2024.
Okay. What type of backflow preventer would be required on the water connection of a salt ice machine?
On a ice machine or well, ice machines, that's a great question, because ice machines, they're challenging in that there's so many different ideas of what's around that. So an ice machine that makes, we're talking a nice machine that you have in a restaurant or in a hotel lobby or something like that. It depends on the cooling condenser. So if it's an air-cooled cooling condenser that chills the water, that's used to chill the water, then it's considered a minor to a moderate hazard. And it's integral to there might be an air gap inside. It does not need anything major for backflow. But if it's a water-cooled cooling condenser, it depends on this is more of a complicated question. It depends on the location of the solenoid in relation to the coil in the cooling condenser. So if the solenoid is downstream of the coil, it's a severe hazard, the cooling condenser only, and that gets an RP. If the solenoid is upstream of the coil, it's a minor to moderate. And so but in the application of a backflow preventer, make sure you isolate the cooling condenser from the water that's going in to make the ice. So a lot of these are installed incorrectly. They put a backflow preventer on, isolating the condenser and the ice, and that way the contaminant from the condenser can go into the ice water. So those should be separated. So the CSA has changed its mind on ice machines for millennia. This was a minor, now it's a moderate, then it became a moderate, now it's a severe, and then it's all over the map. So it really depends on if it's water cooled and where the cooling condenser is in relation to the solenoid, the coil. So without a diagram, it's challenging to show you that, but that's what it is.
Could you expand, Trevor, on the problem with CO2 and copper in a pop machine?
Right. So CO2 is under like 1500 PSI in a big tank. And then there's a set of regulators that go from 1500 PSI to like 500 PSI down to 50 PSI. And that CO2, because it's all under back pressure, it makes the bubbles in our pot machine. And anyways, if the regulators fail in any way, and that tank increases in greater capacity and pressure, it will back pressure through the mixing valve. Now, it has this, unique chemical component that will dissolve copper. So what'll happen is the gas is what it would be. The gas would back pressure into some copper piping, and it will just sit in there. Because if nobody's using it, getting a pop right now, it'll just sit there. So the longer it sits there, the more it will just start to, it dissolves copper on contact is what it does. Not familiar with the chemical component of that, and it will just break down that copper and sit in that pipe. And then a day later, 2 days later, the longer it sits, the more copper parts per million you're going to get in that supply. So then the next Slurpee you get, or pop or rye and Coke or whatever it is you're getting, that will contain high parts per million in copper, and then your stomach doesn't do well on that. And it's probably one of the most common cross connection incidents that are out there is a pot machine. That's why when you install these pot machines, they say, ensure that there are no copper piping anywhere in this area. So it's all plastic. But I see people putting little copper 90-degree elbows, or they'll use little copper fittings to put things on, and those are red flags too, because we use copper for a lot of fittings and things like that. So it shows up more than you think. So it's just something to keep an eye out on that. So
yeah. And as per guidelines of Canadian drinking water quality, copper is an aesthetic objective. It's not a health objective. So,
normally, yes. Yeah, so it's still considered potable piping, but it's a unique blend of that chemical and copper. They don't go well together. So unfortunately.
Okay. Actually, I had this question for you yesterday when we were practicing. Any significant difference between the AWWA cross connection control manual M14 and the CSA B6410?
Yes, excellent question. The AWWA M14 still is referenced in the appendix of the plumbing code as considered good practice for the installation of backflow venters for fire sprinkler systems. So that's where it shows up in the plumbing code. It references fire sprinkler systems, and M14 is a good practice. Now, M14 is an American standard and was used quite a bit. In fact, that was the only standard we had for the many, many years, from in the 80s and 90s, right up. But in 2004, 2006, the CSA came on board, and we started having our own standards. And so prior to that, we were using the University of Southern, or the AWWA Pacific Northwest section, which was another standard, and it's still available down south, but we use that through BC and up into the Yukon. Now, when CSA came along, they made a standard, and so it was there, but it still wasn't being followed. But in 2006, it was adopted into the plumbing code as a mandatory thing. So then everybody went, okay, well, AWWA is now, off the shelf, because the plumbing code says mandatory requirement, follow the CSA manual. And the CSA is fairly hefty on the application, and it covers everything. So it's very well done. Submitted by a group of people. It's a federal or a national sort of standard. Now, the difference in those codes are, the AWWA only uses two standards, severe and low. Well, in CSA, there's minor, moderate, severe. And so on AWWA, their low is our moderate. and the high is the high, that's no problem. But there are no minors in the AWWA, respectively, to what we call. So it just became this big confusion. And a lot of cross-connection programs were still saying, follow the AWWA, but then the CSA came out and nobody figured out standards. So it just, so they contradicted each other is what was happening. And so it's since been sort of just, you know, it's still available, but nobody's really using it as, you know, as of 2006 because the CSA is became a mandatory component. And to use the AWWA for application contradicts the CSA. So then you're back pulling out, repairing things. It's just, you know, so it's still a good manual. It's still good for practical reading. It just doesn't really have any teeth as far as the plumbing code goes now.
Are there any specific items that a gravity-fed water system should think about in terms of cross-connection controls?
Yes. So the higher so the facilities closest to your reservoir, the upper elevations are the greatest subject to, they have the lowest pressure in your utility. They're greater subject to back pressure conditions from internal components. So if I have a you know, a commercial facility or, you know, that is running upper elevation of my gravity feed system near my reservoir, it doesn't take much to overcome that pressure by internal back pressure, by heat or something like that. So for smaller utilities, I would, if I have a small little industrial area of town, let's say, where is that hydraulically located in my distribution system? So if I'm up near the top of my reservoir or on a bench up top or somewhere elevated, if I'm supplying from below even, those are red flags. I need to focus on those, figure out what my pressures are there. But it's the upper elevations you have to worry about from a gravity feed system. Down below, you've got a ton of pressure, you know, with pressure reducing valves, you know, breaking that you know, the pressure up into manageable, you know, pressure sizes, so that we can deal with. So not an issue for necessarily back siphoning there, but dead ends that run parallel in your systems can also be subject to greater velocity flows and things like that. And so it really depends on if you have looped systems or dead end runs, different elevations where your pressure reducing valves are located. But overall, just in general, the upper elevations near your reservoirs, greatest subject to back siphoning.
Next question, what is the best way to inform a small community regarding backflow prevention?
That's a great question. I've had over the 20 years, look, there's been a lot of approaches here, and it can be as much as just flyers. They're very impersonal that way. Some people send out flyers. I've had really the biggest success I've had was a small community that did a little an open house day. They just had an open house on the water system. And because a lot of folks know, they don't know where water, turn on the tap, water comes out, flush the toilet, goes away. That's as far as anyone thinks about. So to introduce people into your community as to what water operators do, what it is we do on a daily basis besides drive around, there's other things we do. So it's important to bring the community mayor or chief and council, invite them in, and not everybody's going to show up. So you have these once a year, and you can talk about different subjects, and cross connection being one of them. I've even had water operators work with the local school to do a thing on in the science lab about backsiphoning and backpressure and how this impacts a water system and water conservation and different things that you could utilize training through education through schools. So there's different methods. Be creative. Bring some, cake and donuts and coffee, and you'd be surprised who shows up. And it's one method of doing it. A website's another way to engage people. Don't beat them over the head with a bylaw. Let them work towards protecting the water, not forcing them to protect the water. So there's different education components. Be creative.
Yeah. Thank you.
There's no wrong answer there.
Is an ordinary check valve considered a cross-connection control?
Single check valve assembly? No, it doesn't exist anywhere in any standard that as a backflow preventer. So a single swing check is metal on metal. You know, your typical swing checks are not considered a backflow preventer. It doesn't show up in any of these standards as a backflow preventer. It has to be resilient seated, which means a soft rubber being pressed into a hard seat. And these single swing checks are not that. So they don't really qualify or are acknowledged by CSA as an approved backflow.
Yeah. In reference to the copper and pop machine, would a brass have a similar hazard?
Yes, to some degree. There was a lot of debate on that. So for example, brass, the older brass here had, you know, the metallurgy in here. There's lead in these things. There's brass and there's a bit of copper. Now, it was deemed by studies down in the States. University of Southern California did a big study on that. And, you know, because at first they thought, okay, well, it has to be a stainless steel type big backflow preventer. There's a stainless steel backflow preventer there. And that's what they were, you know, $1,000 a piece. They were asking for, but then they decided, you know, it's not so much they did the study on that it's going to be any issue, but the little dual check with atmospheric port that I showed in the image of that you'll see if you look back on that image are stainless steel. They are made out of stainless steel, but there's still some brass that would have a small amount of copper, but not enough to create any issues. But what I found most concerning is people would go, well, we're going to install a big testable backflow preventer on there. And then they would install a bunch of copper components to put it all together and then null and void the whole works. So you're best to just, you know, whatever comes with the mixing valve from the manufacturer will have that little dual check with atmospheric port for carbonators on there. That one should always be replaced because some people, it'll leak, they'll take it off, throw it in the garbage and direct connect it. So that's why inspections every year are good or things like that to ensure that they're fine. But as far as the brass go or copper in that, there's not enough to create any issues.
Okay. So there's a lot of like jurisdiction issues. So you had mentioned in the presentation that the plumbing code is a guideline, or is it like
Nope.
you said that it's been adapted, or it's become it's a legislative requirement or whatever for installation and assemblies, and then of course doing inspections and so on.
Right. So the application of a backflow preventer, the requirement of a backflow preventer is mandatory for any new plumbing system that is built. So there can be no unprotected backflow or cross connection, not even an outside hose bib. So, and that's for anybody pulling a plumbing permit, change of occupancy, or new building. So what isn't in the plumbing code is annual testing and maintenance. That is at the back of the appendix. So all the plumbing code is asking for is saying it's got to be there. After that, it's you know, it's outside the jurisdiction. So this is why for water operators and small systems, you have to have a means of enforcing that testing to get done. In some cases, the municipality is so small, well, they'll just test them. We only have 3. We're just going to test them all, call it a day. They get done, they're tested. Not necessarily enforce the customer to do it, but in other utilities, like a larger utility, it's the owner's responsibility. That's put in a bylaw and enforced through a bylaw. So testing and maintenance is outside the scope of the plumbing code. But the plumbing code, you know, backflows have to be there across the country, and they refer to the CSA B6410 as how to do that, the installation criteria. You know, this is the hazard levels, minor, moderate, severe, and this is the backflows that need to be there. So that's what that book does.
And then about the repair kits, are they fairly generic, or Are they specific to the type of assembly or device you have?
Yeah, they're you know, it depends on the model, make, you know, the manufacturer, and that specific backflow preventer has to have a specific repair kits.
Okay.
And I find a lot of, you know, in Canada, there's housing or plumbing outfits will carry the entire kit. And the bigger this backflow preventer is, the entire kit can be thousands of dollars. So if all I need is a new spring or a new rubber check, you know, it's really hard to allocate that or purchase that in Canada. So there's a company called bavco.ca in the States that you can buy individual parts from. So it's used quite a bit in Canada for acquiring individual components. Or know your part number, go into a plumbing supply wholesaler and order that part number from the online manufacturer of that backflow preventer, and they should be able to order that for you.
Okay. Thank you so much, Trevor. I think that's all the questions we have from our participants. Thank you for that wonderful presentation. If anybody has any more questions, please post them to the website and we will forward them on to Trevor to answer. So thank you everyone for attending. Your CEU certificates will be issued in day or two, and then they can be submitted to EOCP for your CEUs. Our next webinar is going to be on June 18th, same time, same day, corrosion control for small water system. So that's our next webinar coming up in June 18th. So please don't forget to register, and we look forward to seeing you then. Thank you so much.
Thank you very much.
Thank you, Trevor. Awesome presentation. Yeah.
Somebody got some value out of that. You guys take care. Bye now.
Thank you. Bye.